Hi everyone, welcome to this tutorial. To give you an overview of what this tutorial will be about is we're going to create a very fake kind of social media advert for a chocolate product. Welcome back. So now we're going to go into effects. So again, I'm going to go into the LOP network effects. If you recall, we are importing the animation and we're kind of importing the cameras and the new animation we've got. So again, I have a null that says 2 shots and it's going into this shot. Now the effect, if you remember, if you remember this, or if you remember the crappy effect I did, which is the egg breaking open, and then we've got another variant version of it. It's just like a viscous fluid pulling apart. So we'll just set something up really quick, and we're not really looking for an award-winning effects pass here. We're just looking for something to come in and out and just see how this all makes sense and how we can, well, work in this manner. So I'm going to go into this LOP network, and again, it's the same thing. I've got my effects department, and I'm extracting, well, another LOP network for the asset, and then we're going to jump in, and it's kind of repetitive where we're inputting to shots, so it's the same. And I'm creating an output structure, which we'll talk about in just a second. Now it's very similar to the animation where we have the shot, the department, as you can see, is now effects, and the asset is op name, and it's going to be chocolate, and then I'm just adding / fluid because I think it's the closed version I kind of manipulate, and it is the fluid, so I've just named it fluid. So I know that basically when I save stuff out, I'm going to save it on disk in this kind of way. So, and this will make sense in just a second. So I'm going to create first of all, before this is where we do all of the effects work in here. Okay, and I'm going to create a layer save path here, which if I middle click on it, it's just going to save the asset down into the shots 000, because this is an effect that spans across all the shots, into effects, the chocolate egg. Then the actual component, I'm creating a folder here, and it's USD data, and then I'm going to kind of record the name of the effects SOP here, and that's what I'm going to call this. So this means I could copy and paste this and have, you know, back in Houdini world, as many of these versions as I want. And then later on we'll look at this geometry clip sequence, and then just popping that back in and sublayering that on just to test proof of concept that this is all kind of working as it should be. Then we'll also look at creating a proxy simulation geometry just so it kind of matches up. Whoops, let me just quickly space G that. My goodness, space G that. Just so that we don't have the heavy fluid in the viewport. I just had some poly reduced version there, so if you don't have that, you know, you've still got the old stuff versus the new stuff in the viewport. So and this I thought would be useful to do at the back end of the simulation, all within here. So we're going to look inside of here and basically take a look at how I've set this up. So I'll just go to the first frame. So let me go into the setup here, and there's quite a lot. If we just quickly look through everything, there's a little bit more in here than I actually originally had planned. So go to the top, and we're going to bring in the LOP import, and a bit like what we did for animation, just going to grab the input that's coming in. So if I press U, we're going to grab this stream here. So we're doing a layer break, so we don't save anything. We only save what we change is what we're manipulating in here. So because in here we are literally going to grab this, that's the only thing we're going to kind of manipulate and change, and then overlay our changes back in. So even at this stage, you would be able to see this working, but it's kind of live, and it's a little bit juggy because having to process stuff before it's saved. And the reason this only exists is because it's inside this node, there is a cached version that's linked to an output node. So I'll go in and hopefully it'll become a little bit clearer. So the time samples are now set to animated because if you remember, we do have animation coming in. Okay, so that's just something to bear in mind. So I'm going to unpack this. And I'm just going to grab the render geometry because I really just want to work with the render geometry at this stage. Now, at this point, you might have specific geometry for effects, or you might be creating your own geometry. To keep this simple, I am just going to grab the render geometry, as you can see when this opens up, and then I'm just going to start preparing this. So I'm going to grab this no fluid, and I'm going to use this for my colliders later on. So you can see I'm using the name here just to grab some geometry here, and then I'm also going to hold the first frame. So this this is linked to that special framing animation. So the advantage of working in one scene across multiple disciplines or multiple departments is you can link data from right within here. So I think I had a controller in here, this dude here. I'll just go back. So I copied, right click and copied this, copy the parameter, and I pasted the relative references in there just to give me this hold the first frame. There's a reason for that, if I can remember how or why. So what I decided to do is, because this could be your egg in any position from animation, decided to put this into a rest position. And so I basically put this in the rest position. So if we put this in space 3 and I think this is like a back view, but you can see this is kind of like the animation position, which is all it's doing. The animation is rotating, but we may have been rotating it in different ways. But the idea behind this is to put this in the rest position and to use these nodes later on to, well, I'll show you, but we're going to, first of all, don't think we used any of this stuff in here, the chocolate and the exploded view, and I think I was just maybe looking inside at some attributes and stuff I've done. So just to not confuse matters and hopefully won't break anything, I'm going to delete that. But no, I'm going to keep it for now. But we split this, and we split this up because we want to get a source for our flip fluids. So I thought what we could do is use the name fluid and then just soft peak this in a little bit, subdivide it, and then I'm going to create I'm just toying with some ideas, but originally I created some like interesting shapes inside to kind of convert into like objects and bubbles, and then I started doing VDBs and creating stuff that would create a fluid, and then smoothing this out. But I didn't end up using this, found it just slowed things down in the fluid sim. So what I did is I created points from volume, and then I just do a cull where I can cull the amount down and just test things out. Then I did an attribute adjust float to give some random p scale to then generate the particles. So this is like VDB from particles basically, and this will basically p scale will create that. Let's not do that. Oh dear, I crashed Houdini. Let's just bring that back. This will create p scale, and then I can do a difference, and I can just cut out some air pockets. And I thought that might be interesting to kind of smooth that out, and then do another smooth, and then convert this into a piece of geometry. So this becomes a piece of geometry that we can smooth, and then we'll have this piece of geometry that is full of like little air pockets and negative empty spaces for like caramel something. So that was that, and then I smoothed the mesh. Not really sure how important the smoothing was, but if you remember, we need to then do an attribute cleanup. so that this geometry is like super clean. And then I create a rest position for this. And what I need to do now is your object may require you to you sometimes kind of want to do stuff in back at the origin and stuff. So this is actually back at the origin because we did actually set it to the rest position. So what I'm going to do is get the out rest position here into here, and then hold first frame here. So if you look here and here, and I'm going to point deform this. So I'm going to essentially put this back in the start position. So you probably can't see, but if this was kind of animated and spinning around, this would have been kind of, you would have done all your VDB work and stuff, and you could do your bounding boxes relative to the world space, like top Y and negative Y, and everything like that would have just made sense. In fact, it'll make more sense when I show you why in just a second, but it allowed me to put this back now to correct animated start frame. Because in the past I did actually create a gap here, and it just allowed me to experiment with a few things. So let's see what this looks like. So we're going to already have this interesting fluid emission, and then I would save this out, and we'll talk about the saving and where it goes later. But this is interesting. We do an attribute adjust float here, and we create an attribute called viscosity at 0 to 1. Now what I wanted to show you is the viscosity attribute in here. If I just show that, it's literally set to like a bounding box in Y, and it's just mapping this based on the bounding box. So you get in a 0 to 1 fall off there, and that's really nice. So you can create another bounding box, and you can set that one to there we go. You can set that one whatever you like as well. So, and I can add this in. So as you can see, without it, you get this kind of like weaker viscosity of a value of 0 down here, and can composite them together. Then you can remap this to be, oopsie, your viscosity that you want. And mine's ridiculously high, probably too high, but well, this is all effects work that you spend probably days getting it right. Then you can just visualize that with a visualizer here. So you can actually use your visualizer and just remap, treat it as a scalar, and remap this viscosity here like so. And then I did like a density as well. So if I turn this off, I just map some density. So I've got a min and a max, and it's the min is just reference to the max plus 10, just to give a little bit of variation of noise, and color the density. Then I'm going to restore this back to the animation start frame. So as you can see, the stretching of my density, and originally my viscosity was stretched to kind of give a longer, interesting feel, but this will align to the start frame of my geometry breaking. So if I just, there you go. So it kind of aligns to it. So it's just creating this interesting way of working. So you can actually just have a source that is more easy to manipulate. So the idea behind this is when I'm working on these attributes and I'm using these kind of bounding boxes, this has no animation on it. It's kind of just being restored to its original rest position. So space 3, I can do things like this, and then know that it's kind of easy to calculate, like gradients, I guess, is what I experimented. So I kind of Really didn't need to do any of this for this demonstration. This is not really about, the idea is you just could have just plugged in VDB without the holes in it and done a viscosity attribute just to test it out, saved it out, put some attributes on it, and then I do a little cleanup here and just make sure that this is now going to feed my flip tank. So I've got a flip tank here, and it's quite a large particle separation. So I think, what did we use in the end? I don't think we went too high. I think so. We ended up using something like this, and then so yeah. So you feed this into the flip boundary, and I emit again at that start frame 1005, and then it emits. I think it emits on my given start frame. So my start frame, let me think, was here. So so this is the open egg breaks. If you remember, it's 1005 and I'm just doing a -2. So this simulation starts 2 frames before the animation opens, so it just appears, and then this will emit, this fluid boundary just emits on that frame for about 3 frames, and then it turns off. So that's all. In fact, let's just visualize that. Let's do this. So it's quite large. So let's just take a look and see what happens. It's going to emit, and you're going to get the particle fluid emitting like so, and it's going to emit fluid for 3 seconds, but it's going to be in a collision, because something I've not mentioned is the colliders down here are here, and I'm just doing a soft peak. I'm just kind of pushing things in a little bit. I'm doing a left collider here, I'm doing a right collider there, and then I did separate colliders for each one, which are just kind of feeding in as these volumes and surface colliders. So yeah, that's kind of what was happening here. So this is going to be spinning, as you can see, because the fluid's being emitted for 3 frames and it stops. So it's just kind of way of filling it out a little bit, maybe. And it's colliding inside of this this egg. So this fluid is now this geometry with those attributes on. And again, I just threw this together really quickly, but the egg is going to essentially part. Now you can see the particle separation, everything is not going to be efficient for a final simulation, and that will be just like a separate tutorial about the flip fluids. And I've chosen to do the flip SOP, and I could have used DOPS, I could have used, I don't know, vellum fluids maybe, or tried the NPM solver. This is the point where you just extract USD data and do stuff with what you want, and then just be aware of how you export that back to Houdini world. So I think the viscosity is probably a little bit too much on here as well, but you can see this is kind of pulling apart. You see this fluid is kind of sitting inside our collider, and it's, you know, there's quite a lot of surface tension and everything, and I'm not really happy with the fluid sim, so I'm just gonna tweak it a little bit. So I've got the flip source, I'm happy with that, and my attributes are kind of live, so maybe, I don't know, we remapped this viscosity. I think it could be maybe minimum, maximum, maybe 800, maybe the minimum could be, I don't know, 700. Let's see what happens. Hit reset on that. And obviously all these attributes take time, so you could wedge this, and I have set up a wedging system in here which will go through and wedge and flip book and put some annotations against each flip book, so we'll talk about that in just a second. In fact, it's kind of a side topic, but I thought it'd be something interesting to add in here, but it should really be a separate tutorial, I think. But what we would eventually do is, as you can see, the fluid's kind of pulling apart, and it's going to be really viscous around the outside, and then it's going to be a little bit less viscous on the inside, so it should droop a little bit. Now, probably not the most efficient way of doing a fluid sim, and but it's showing you how we've took out a piece of geometry and we are creating new geometry, essentially. So what I would do is I would go ahead and let that simulate. I'd play around with the settings for a few days, but I would also, before I get where I need to be, I would probably wedge this. So the wedging itself, what I decided to do, and if you've done any kind of wedging, you'll know that you can usually involves having to set up a top network, and inside the top network for the wedging, I've created a bunch of parameters. So I'm wedging this way. So I'm wedging where I'm directly going to grab the attribute to wedge here. So you can see this op name, and so this is, you know, one of those things that if you're copy and pasting and you're changing the asset name, then this direct target parameter is a different way of doing it, but it means I can grab, just to give you an overview, I can grab attributes from the flip tank. You can see this is a particle separation that lives on the flip tank, and this is the attribute name, and this is surface tension is also on the flip tank. So I can set particle separation to one value, and then surface tension I can wedge 3 times with set values 1, 5, and 10 maybe. Then I can do the same, and again I've got this normal stick scale, and this is kind of sit on a fluid dop. So this is kind of where I'm literally going. You can't seem to navigate to them, but what's happening is it's going to pull in attributes from the flip tanks. It's going to particle separation, the other one, the surface tension, and then the fluid, it's going to change some things on the collisions, normals, and tangent scales. So we were just wedging those as an example. So, and the interesting way of doing it this way, rather than doing it like if you wedge something and we do a wedge and we don't do a target parameter, and we create a attribute who, and you create a value, right? Let's do a value list, and you do 2 of them, so like 10 and 20. You've now got 2 wedges that this thing's going to run over, or poo, and you would take that attribute and you would have to place that in here like at poo, and then that breaks this parameter, it breaks this setup. And if you're doing that all the way across everything, then you have to like evaluate this node to evaluate this wedge, so that this attribute can kind of be exported into these parameters. That's a perfectly valid way of working. But I didn't want to change anything about my setup. This was my main setup going into my export, so it was kind of getting exported into disk. So I decided to kind of create a separate export that these wedges exclusively change the parameters, and then it just runs this sim, which is this DC sim wedge, which is this guy. So it's going to run all the simulations into a unique set of folders in here like that. So I did it that way. So, you know, I didn't opt to do it this way where I would do it the way that you may have seen in other videos. Apologize if you've not seen either way before, but there's tons of tutorials on wedging. This is not a tutorial about wedging, but I would run the simulation, and then I would flip book this, generate the text file, and partition by frame, do a constant sheet, and then the final movie. So this, you can pick up all this in the, I won't slow the tutorial down because it's not about the wedging process, but if I just quickly give you a preview of this, if I virtual and generate the static work items in here, you'll see we're going to get like quite a lot of wedges. So, and it's going to take quite some time, and you know, you want to be careful with this because you want to run this kind of overnight, or you could just lower your frame range to like something that you find interesting, and it's going to run just that amount of frames now on those amount of wedges. So maybe we didn't want to wedge all of these values, but you don't want to delete them. You could just knock it down to 2 values. And then if you generate a static node, it's going to have less iterations. So it's going to be 12 iterations of simulation. So let's just show you where that goes. So again, in our chocolate egg, it's going to go into shots, and it's going to go into it's not really shot specific, so I'm going to put it into effects. It's the chocolate egg, and there is going to go into hopefully fluid, because that's what we're wedging. So we can kind of see this by looking at this ridiculously long string that I've created here. You'll kind of see that's going to go into the shots 000 effects chocolate egg fluid geo, and then the name of the asset, and then it's going to go into DC sim wedge, and then a version, and then it's going to be wedge 1, because we're using this wedge index and another one of these controllers, which I haven't really talked about yet, but this control is kind of like deriving the output of all of these to be quite procedural, and it's defined down here. So again, this is kind of like, this tutorial here is probably going to become a bit long if I go down the route I want to, but what we could do is wedge everything. So in the morning we could come to a contact sheet and all the simulations and just pick one we like, and then maybe finally set off the main one. So just to show you where this all goes, I will hopefully be able to make sure my export flag is down here like so, and then up the output, save this. And then what should happen is we should start to see, as this moves through, it's going to very quickly generate all of the attributes, and then it's going to start to simulate, and it'll start to simulate, oh dear, something's broken. Missing attribute wedge index when evaluating file work item. Wedge index? Talking about. Oh dear. So when we run this, it's going to quickly run through and set those wedge values, and it's going to go through and run. Actually, what I'll do is I'll right click on here and I will work item info to bring this up here like that, and then hopefully it'll remember. And there we go. So it's going to run this simulation into the correct place. It's going to be shots effects chocolate egg, and then the fluid geo, because I'm calling it geo because it's kind of Houdini stuff, not USD, and fluid effects, so it's kind of getting named off of this. And then it's going to be DC sim wedge. Unfortunately I've set version 2, but it's probably fine. And then it's going to be wedge 1, and then it'll be 0, wedge 1 to all the way up to however many wedges we get. So we'll get this like unique set of folders saved on disk. So this, you know, could take some time, but eventually what you'd end up with is hopefully just like I showed you before in fluid geo fluid effects. You can see where my flip source was before, and the remesh and the sim. So there's a little hint of where everything's going to go from the effects team or from me. And DC sim wedge version 1, it's going to be wedge 1, and you're going to get the simulation saved there. And then once that's all done, you might be thinking, how is this flipbooking? And it's actually going to take this node, unpack it, and display the points. So if I can get this to preview on the correct frame, let's just check that this is actually evaluating something half decent. So let's have a look. So we're on frame 104. Seems very slow. 104, 105. It's interesting. It should have returned. The particle separation isn't anything crazy. It should have returned some simulation data that I could have shown you. So I'll return when this is done. So it's not really done much. I need to investigate why, but it has actually gone to 105. So I'm going to press U and just go to frame 105, and you can see it's doing the particle separation as we expected at whatever value we had here, quite large, 0.01, good for testing. So it's kind of been loaded in here and it's been unpacked, and then it's been sent out to and what I'm going to do is I'm going to create right within here an object network, and the object network is basically going to pull in the sim wedge. So it's going to pull in this, I'm going to pull this into objects, it's going to pull my collider in, and I'm going to carve the collider and just create an alpha just so I can kind of see the points like that. And then I create a camera called wedge cam, which was actually sat right at the object. So it's the only thing that is sat in objects at the moment, which I don't like, and I will figure out how to get this more kind of back into Solaris. But if I go back, and then back, there we go. So we're now like in the effects department in a object network, just so I can do a blooming flipbook. So hopefully that makes sense. But when this is flipbooked, it'll flipbook the background won't be this color. It will most likely be the one we've asked it to be. So it'll be more likely be something along the dark gray category. So it'll look a bit like this. And it will have some writing here, and we can now take this data and kind of make this object level, which is now a geometry, flipbook however we like it. So that's the thing that will be flipbooked. So you know, if there's another frame and another frame and another frame, another frame, it's going to flipbook this as this opens up. Oops. You can see it's going to just flipbook and give me something. So hopefully that's not too confusing, but that's kind of what this flipbook is going to do. And once it's done that, it's going to bring those images in and add some text. And that text is pretty much the overlay. I'm taking in the, you know, the human readable thing that's going to appear along here. So you'll have particle set, and then it'll return the value of this at particle set, which is this value is this. So it'll kind of list all of the parameters and things like that. And that's why I've colored these blue and I've colored that one blue, because whatever parameters you create in here, you can actually declare them in any name here, but you need to pull in the attribute, and that will resolve the attribute, and its values will be presented in each wedge within each flipbook when it's kind of placed within the contact sheet. So, and that's what that's going to do. That's why this one's, you know, a contact sheet. So I'm not going to go into this too much, but this is kind of been working okay. For some reason it's a little slow today. I don't know why. I'm not going to wait around for this, but okay. So the simulation has finished, and it did wedge about 8 versions, and it did take all night because I actually run the whole thing and just left it to go just to see what had happened. And I did, if you remember, I did a very, you know, large particle separation, and I wedged just 2 of the surface tension attributes and just 2 of the normal scale and tangent scale as well, and that was it. So it's run the simulation, and it's run the flipbook, and it's run the text. So the way I've done this, if you look at the node here, the path here and here and here are the same kind of expression. That's kind of my expression. So this control here is actually coming up from my my controller in Solaris. It's the effects path, so it's just basically concatenating on top of that and then deriving names from all of these kind of stages up here as well. So the op name would actually be, if you see it says chocolate egg geo, it's the op name is this. So what's going to happen is all the data is going to go into this geo into fluid, and it's going to go into this DC sim wedge. So DC is, I just add disk cache so I could search and find them a bit easier, but that's my master sim, but my wedging's going in here. And you have a version. I don't know why I did version 2. I must have just left that version on, but it's fine. and it's going to go and wedge all the simulations into individual folders. And then this image folder is kind of represents all the images for the individual sims. So the first process is the flipbook. If you remember, we had the, oh, where is it? That we had the flipbook here, and that's now been saved out into all these individual wedges. So you get like a flipbook. You can see that's kind of doing its thing there. So once it's flipbooked, that gets fed straight into like a node where you can kind of add text and things like that, and that's the node that's just called the ROP composite node, and it's the same path, but it just inherits this $OS. It just inherits this name text. So because of this string here right at the end, these $OS's, it just sticks it into a folder here called text, and that is going to basically put some attributes. The wedges, it's going to put the wedge here and the particle separation. Now I didn't actually set up the stick distance, so I should have just removed that, but you know, lesson learned. And this is on an alpha, so you can see you've got the wireframe, the wireframe, the carve, and the alpha that we set up, and the point's kind of doing its thing here. And this is on a background. This is on a transparent background. So this needs to go and get some kind of background color. So we kind of set all these out with a partition by frame, and then we set up the contact sheet. And the contact sheet, I've set it to be 3 by 4, and this takes a little bit of back and forth. So you might, once all these are done, you might find yourself constantly trying new settings on here, right clicking, dirtying, and cooking the node again to get this right. So the one thing to be aware of is if these are set to automatic, if there's data on disk, these won't rerun. So that's good to know. But if you force it to write out, like if I try to rerun this now and said automatic, because I wanted to change the columns and stuff for my contact sheet, which I'll just actually, while we're talking about, I'll just come back up to here. The contact sheet is here. You'll see a contact sheet, and you see now it's on grey, and that's because I've put grey 50%. So you can actually add different colors in here if you wanted. And I think you can change the text color as well in the text inside of here. It's just a Copernicus network now that you can modify with the drop shadow, because I kind of tweaked the drop shadow a little bit just to make it do that. That's probably enough information for me just to test this situation out. They're not looking too different, to be honest. But yeah, we should probably see that play. But at this point, you wouldn't need to do an MP, a dot movie or whatever kind of movie you'd want. You could just throw those into an image editing software just to take a look at them. So there's this software called DJV, yeah. And it's kind of it's an EXR reader, and you guys probably know about it already. You can just chuck that in, and this will be quite a large file. So you've got like the full resolution, and you can just play that and take a look at the simulation and start getting quite nerdy about all the different stats and settings and things like that. Yeah, and then of course you can change the camera and stuff in your wedge and just put in what you like and stuff. So that was just kind of a proof of concept, just to kind of wedge some stuff out. So yeah, and then the final movie, I haven't run it yet, but I can just, because I deleted it because I was tweaking this. So for example, if I change this to like 2 and try to read dirty and cook this node, it didn't do anything because this is set to automatic. But if I set this to write, it would write all new stuff. So let's just try and take a look at what we had. Actually, yeah, 3, 4. So maybe you just needed 3 by 3, right? So that would actually do the same thing. So if you kind of want to just work out how many wedges you have, and then just work out each square and how that would fit in there. So if I set this to right, it would change this. So if I set this to, this probably won't work, but if I just set this to light blue, and then if I delete them on disk, then it will actually, it should in theory regenerate them with these new parameters anyway, with it set to automatic, because it can't find them. But you could have just set it to write and it will write over them, which can be quite useful if you're missing frames or something. I don't know if it's going to work. Contact sheet, I don't know why. If it, oh yeah, light blue, that's hideous. So I'm going to cancel this node. I'm going to dirty this node, and then just revert that back to my previous well, black. I think we just set it to gray 50%, so gray 50. And if you notice, we have them there, but if I set this to write and then right click and dirty and cook this node, we'll force this over, so it'll just start writing over these. So you'll see this should go back to gray, whereas the other ones are still blue. But eventually they will all become gray. So I'll set that back to automatic maybe when it's finished, and then we'll look at making the movie. So making the movie, you kind of need to have this file kind of saved out. It has to be this kind of special file here. It's don't know if it needs to have an index. That's interesting. Maybe it does. But yeah, again, it's the same path, but now I'm going to just save it to that and set up the parameters. I often don't use the QuickTime because it's quite handy, but I kind of would just make this myself, but it will run, but it can be quite more difficult to do this way. But you could imagine this could be something that you could email yourself or something, because I think there is actually an email, send an email afterwards and email yourself the actual attachment. Oh, I've broken it. Okay. Okay, so dirty this node and go up and I'm delete that, and I'm going to set this to automatic. Control S. I'm going to just go ahead and just do the whole thing, because we are really sidetracking here. So dirtying, cook this node. So it's going to cook this guy. This won't start because it's waiting for all these to finish, hence the wait for all node. So this is going to go ahead and carry on doing the contact sheet that we did. Going to get these. So we have a gap, but I don't mind because, well, that's how many wedges we've got. So you can just set this up how you feel best for you, really, what colors you like, how you want to display geometry and things. So yeah, I'll be back when this is finished. Okay, so the contact sheet is finished. So we have this, and it did run into the movie. I'm not an expert on the this node and the making the movies. I don't really do it that often. In fact, it did actually work, but I don't think it's a very high res one. If you look at the contact sheet, you look at like how much detail you can see here versus the movie. It gives you a quick idea of but it's difficult to read. Even if I put the native resolution, very difficult to review, especially with this type of player. So I actually do create this just to kind of quickly look at it, and I will be looking into making a better, setting this up a little bit more so it's more presentable in the future. But at least we've got the basics working. But I think it's just a case of reading about the help about the types of formats and the resolution limitations of those as well. Yeah, I'm not an expert in any of this at the moment, but what I do like to do is I just kind of chuck my contact, because it's really just for me. It's just some feedback. So I just grab the first frame, double click on this, and then you have this this way of working. And once this is cached, it's not actually that painful, and you can kind of at least zoom in and say wedge one, and you could even just put this in. You can get your DaVinci or After Effects, whatever, and just make your own movie. So it's a slight deviation, but this is the wedging kind of setup that I just put into place. Okay, so when it comes to saving all of this stuff, you'll notice that I have and I may touch on this later on, but I have this run all, and it's just another topnet. And essentially all I'm doing is I'm grabbing the DC flip source and the DC sim and the DC remesh, and then the FX USD. So these particular nodes here are actually the stuff inside of in here, and then this is the USD that's going to get made. So what you'll notice in these fetch ROPs, it's got DC sim. So if I just jump through, you'll notice I've got like a remesh node here, and then I cache my simulation out. And before all that, I sometimes cache out my source file and things like that. So the location is driven via a combination of things. So this controller here, currently it's not using anything in here at the moment. So just bear that in mind. It's using, these nodes are using the path that is set up. So go up. It's using the path that is set here. It's just taking that path, and it's using this path, and then essentially it goes geo opname $OS. So opname is going to be fluid, and then $OS is going to be this cache, and then the version is sim version, and then the name of the node again is going to be whatever node we're on. Which one is it? DC. So it's going to just go into there like that. So a bit like we had the wedges, we had the shot directory, and it's going into this effects directory, chocolate egg fluid, and it's geo data. So they're going in here. So it's like flip source, remesh, sim wedge. So I'm kind of keeping all this data relevant to the first of all, the shot, the department, the asset, and the component within the department, within the asset, should I say, and then the actual like working out environment or something that we wanted to kind of do stuff in. So I'm kind of working like that. It might be a bit overkill, but it's kind of allowed me to really partition off my work and experiment. But it is a bit of a setup, and you don't have to do that at all. So that means that this node, this path, is pretty much the same in most of these. The only difference between this one and this simulation, this file cache will have a simulation checkbox on there. So it initializes the simulation, saves data out, and it makes sure it all saves it in like one batch. And this basically is not a simulation, so it could do many frames in different batches and whatnot. And so, and same with this is just the same kind of thing I'm saving out. So if you see all of this, it's why I've done that. And this is quite nice, because once you are happy with stuff and you've kind of spent time doing your wedging, and then you want to do stuff, you can just let these top networks do the work for you. So once this is all run through everything, you'll notice in my top net it did this effects thing here. So if we just go here, you'll see we've jumped out of this node, which was in here, and now it's just going to bake that down, and it's going to bake out all of the USD garbage, and then eventually we can come back out of here and we can test it out, it's working, and then hopefully it's all kind of working. So that was just a little word on saving data and how I'm handling it as well. So yeah, there you go. The simulation, the points are unpacked. So let's just unpack the points, and let's just get a couple of interesting points. Let's just set this back to my original frame and then just get this open a little bit. There we go, something really hideous. So what I've done is I've done a VDB from polygons, and I've just basically as VDB from particles, and I then essentially surface this. So you can surface things however you feel fit, and we're just going to create some geometry. So I'm just going to quickly blow through this bit because it's not about the tutorial, but essentially I do all of this and I clean up the attributes, and you end up with a piece of geometry like so. So you end up with a piece of geometry like this. I didn't really use the color, to be honest, but it's there. And then what I'm doing here is I'm going to object merge in the effects, the original geometry that's going right back up here, and I'm just going to copy and steal across. I'm just going to blast away and just get the original geometry that this becomes the effects, and I'm going to get the path name, and I'm going to steal the path name, and I'm going to get the USDX form, and then I'm going to set this to the correct space so it's correct when it goes back into USD world. Add some normals, and then I'm going to I think I smooth the normals out a little bit, just helps with the rendering and stuff. Again, not the best simulation and remeshing and things. And then I'm going to poly reduce this, and I'm going to clean away any attributes I don't need for proxy geometry. So this will be my proxy geometry that just gets baked out on the fly, and it's going to be saved in with the main geometry, but it's going to have a unique, it's going to have the same name, but it's going to have a unique path, which we will use the proxy. We'll create the proxy path. So we'll take the original path that shipped with this, so we'll know where it came from, and we'll copy the path back in onto this geometry. So hopefully when this is remeshed, it will make a bit more sense. So this is the remeshed version. So this is going to be the proxy. So if I just go to primitives and I hide all the attributes and I look at the name and the path, well, this is what came in. And I got that from over here. So I kind of stole it from here, and you can see that our effects doesn't have a name. Now you can just write this in with a wrangle node or any means, but I've just copied it in this way, so it just means I don't have to remember it. It's probably not the best way, but it's kind of making sure that every one of those points on this fluid simulation geometry has now got a path and a name that was the original thing that came in. Remember when we had the geometry without the fluid effects? And then same with the USDX form. I'm making sure that we essentially copy that over to our point, points. So we've got this USDX form, so that we can make sure that this is in the correct space when we do this to it. So this can get quite confusing, but it means that our poly reduced, and we can then clean away on any attributes that we don't really need, keeping this a bit lighter, and then we can create the proxy path. So this is going to be the proxy now. So the only difference here is it's changed from render to proxy on this stream, and that's just using this s@path path equals replace, and then I'm replacing render with proxy on this path. So and then that gets merged in. So it's actually two pieces of geometry overlaid, which I'm going to ship out, and that's going to do a group cleanup, fluid group. I'm going to call this fluid group, and then I'm going to remesh this, save this to disk. So I have this run all thing going off, which essentially is going to run, well, it's going to run all my setups. It's going to run the flip source and the sim, then the remesh as well, and then it's going to make the FX USD for me as well. I didn't use any of this in the end. I didn't do a render and stuff, so just bear with me. But you'll notice it'll have these nodes. If I click on this, you'll see all these little kind of dependency links, kind of there's sim there, and there's a fluid. So it'd do the fluid source, we'd move everything through here, run the fluid sim, do the predefined remeshing and everything, and then it'd kind of do the preparing for the USD export, where we would clean up attributes and copy names and proxy paths and get the purpose correct, get the correct space, do a proxy geometry, and just bake it all down. And that would be my effects geometry that can go out. And then this section here is going to go back to look dev. So all I'm doing here is I'm grabbing the data like so. It can get really confusing, this part, and I'm going to set this, going to basically set the right world space and clean away any junk and do a group delete, and just make sure that this is exactly how it should be in modeling. So I'm kind of cleaning up any attributes that I require, and then I just save one frame, and that's the geometry that I sent to look dev. So you know, you can give something back, and that can be the model that we saw right at the very beginning in assets, in this chocolate asset here. And that's kind of like, here's this guy, and because he has the same attributes, you know, nothing changes. The only thing that you may notice is the names of the geometry are defined by this geovariant name here. So to cheat, I just hard-coded open here and hard-coded open there. So when I switch back and forth, it just thinks it's the same geometry, except we've got a slight variation in position because it's gone through animation and stuff. But it's not changing, and I've removed all the hierarchy from effects, and it's just changed the geometry. So really faffy, but it is possible to do these things. So this is quite handy to kind of get like something from effects back in, and you don't really want to send this out to the other departments. So that's where you would break this before you publish it. But at least then you've got the ability to kind of look dev something in context in a light rig or whatever. So I'll just quickly jump back into maybe back into effects. So that's kind of like the effects gets saved out, and it comes up here like so. And what else did we do? Yeah, so we're going to use this fluid clip file, and that's going to basically ask me for the primitive that I want to save the clip file to, and it's going to be this fluid, and that's the path as well. So usually they're the same. I'm going to keep that to default. It's going to load in a BGO sequence, so it's going to load in this sequence, and it's going to have this expression which allows USD to read like a BGO sequence. So that is literally just reading a reference of this. So the output of this is referenced straight up into a clip file, and it saves all the clip data. And it's a fluid sim, so you know they don't have matching scene graph. It's changing topology as well. So I think that it seems to be working, but it's kind of save everything into these files, again defined by one of the parameters in here. Oops, and then I would bake this down, and that's the file that essentially gets sent to other people. So I could sublayer that in live and take a look, and there it is. It's got transparency on, so we can turn that off because it looks a bit naff, but you then get like a quick effects pass, and that can be used, and you can make this as complicated or as difficult as you want. I think I kind of went and overcomplicated this a little bit for the sake of this tutorial, but so I do apologize, but you can break this down and play with it and make it your own, or use your own methods. But I'm still learning how to get data in and out, because it's all very well playing with Houdini and stuff, but there is like this new way of working and being aware of like some of these USD tools and how they work. If I come out of this, so we're finishing the effects. If you remember, we published the effects. So this is the effects kind of work, you know, and it's again just a toggle now. So the sublayering is really cool because you can have as many of these files you want, and you can actually control different layers in one sublayer as well. So it's all down to how you want to work, but you can see it's very interactive, and we're viewing the proxy, not the final render geometry. So this is something, again, I'm still kind of looking into, is this kind of, do we need all of this to kind of get this out efficiently? Is it the best way? So I'm kind of reading up on all of this, and I have found a few additional helpful tutorials that I've been referencing, and they've been very, very useful. And I'm actually digesting a lot of the USD documentation to try and get this a bit clearer. But I think I slowed myself down a little bit by overthinking this, when I really could have just poured some fluid. You know, it could have just been a really cheap simulation and stuff, but I kind of started thinking, oh, what if I could just wedge this, and how would a real system, what would we do really, and how would you partition off like your sourcing and your fluid sim and your wedging and your remeshing and your exporting to USD, all these different sections. So this next iteration of this will probably be more kind of structured, organized, and more hopefully streamlined, and contain different methods of simulation, maybe dot fluids or split fluids or NPM, or even just a fracturing system accompanying this. You know, maybe this wants to fracture from, as this thing cracks open, maybe it would be nice if it kind of subfractured there and it flew out in a slow-mo or whatever, or some 10, kind of splashes of things. So we're going to kind of go in our next commercial. We're going to be doing a lot more, but for now I was trying to keep this visually simple, but as you can see in there, it's a little bit more involved. And so sorry if that got a little bit too confusing, because a lot of stuff I didn't actually use and some stuff I did. But again, you can poke around at that file and have a laugh at my settings. But that's pretty much me just trying to get this in from up here. So let's just see from up here to there, and you see the hierarchy is basically just showing me that there is composition arc. So this is kind of just being live. So you come out of here and you go back to this, go in here. Now you've just added in the fluid effect. Oops. Onto this part here. So hopefully that's making sense. So that was the effects. Very something, again, kind of haven't done that for a while, in terms of, I've done quite a lot of effects, but I haven't gone through this kind of USD structure. And some of my earlier tests, I didn't even do any of this. I literally just generated some fluid, and it all just kind of lived in here and got rendered directly, and all the materials were all assigned here, and wasn't really in the more USD structure. I mean, this shader is kind of coming in from the assets, so it's interesting. So yeah, but it is what it is. So I guess we can kind of come up now. We'll be soon enough ready to render, and ready to do some lighting and rendering this. So hopefully tutorial's not been too painful, and I'll see you in the next one, the final one for lighting.